And I also can calculate sine of A cosine of B. We give you 1/2 cosine A plus B, okay, minus, let me see, I messed up the formula now. Sine A cosine, oh, I'm sorry, this is give you sine, sine of A plus B, okay, minus sine A minus B. Okay. Oh, plus, I'm sorry. See, even sometimes I forgot to. Okay, so these two formula, you have to memorize that too. Okay. Okay. Using the same strategy we have over here to get to derive the formula.
So why is that one sine A cosine B? The second part.
Oh, it's just because the product. I mean, we talked about the product to the sum, so the product could be the product of sine A cosine B. You know, because if you use the formula sine of A plus B, if you start with the formula we learned last time, right? Sine of A plus B equal to what? Sine of A plus B equal to what? Last time we already learned. Sine of A cosine. Yeah, here you go. That's why the sine cosine is go from there.
Oh, okay.
Yeah. It's just another formula starting from the previous.
So this is derived from that.
From that one,
okay,
yes.
right.
But I don't have time.
That's okay, yeah.
To go through all of it. You do the same thing. That's why I say you have to apply the same strategy. Then you should get the same formula. Okay. So that is the formula to for product to sum. Okay. How about the formula? Sum to product. Sum to product identity. Okay. 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 What if I want to do cosine A plus cosine B? So we start with the sum and we want to bring it to the product. What we're gonna do? What we're gonna do? Let me see. Or what if we want to add sine A plus sine B to sine B? Okay. Or we want to do subtraction, sine A minus sine B. Or we want to do subtraction between cosine A and cosine B. Okay. What will be the formula for this? Of course, they have the method to derive this formula, of course. And in order to derive this formula, we're going to start from the formula I boxed over here. Because this formula here on the second part, right, I want to convert from the product to the sum, right? And now we want to go from the sum to the product. Of course we have to use this. Okay, we have to use this. But how are we going to use that? And how often we think that we will have to use this formula to do the test? That is the question. Or do we need to memorize that? Of course, I mean, it's helpful if you memorize the formula. Okay? But you don't need to memorize, or you don't need to know the way of deriving this formula sum to product.
Can we switch, instead of B, we write A, and then we have cosine of 2A?
Cosine
Like if we plug, if we equal B equal to A, then we will have cosine A plus cosine A.
Cosine A, you mean you replace over here?
Yeah, just like we did over here.
Oh, you mean you replace it?
Yeah.
so if we replace now, if we replace this with A, cosine A plus cosine A is not cosine 2A. And cosine
yeah,
A,
that's right,
this
that's
is
right.
2 cosine of
That's
A.
right, yeah.
So we cannot add the angle. Okay? So this is what I give you, okay? And I just want you to take it for granted. You don't need to rewrite it, please. No, you don't have to. Some instructor they don't even give you. But I want to give you this because I think that it's helpful, and I think that maybe during the time you do the assignment, you might need it. You don't have to use it, but sometimes it's faster. Sometimes it helps you save time if you use this. Okay? So cosine of A plus B will be 2 cosine A plus B over 2 cosine A minus B over 2. You see the formula is kind of complicated already, you know? That's why you don't need to memorize, you don't need to derive it. Okay? Sine A plus sine B is 2 sine A plus B over 2 cosine A minus B over 2. Okay. For sine A minus sine B is 2 cosine A plus B over 2 sine A minus B over 2. So even for me, every time I write this, I have to repeat it in my brain. Okay. How about cosine A minus B? It's 2 sine A plus B over 2 sine A minus B over 2. Okay. So between cosine and sine, between sine and sine, it's the multiplication sign, okay? So when I don't write any sign, I mean it's multiplication sign. Okay. And whatever I have in the parentheses is the angle, is the argument. Some student in the test, when you do the test, I ask you to calculate trigonometry ratio, and you throw away my angle. For example, I ask you to find a tangent of theta. And when you write the answer, you just write tangent equal, for example, like 1 over 5. And you throw away my theta. It doesn't mean anything. If you throw away the argument, it doesn't mean anything. So this time, last test, I still give you credit. So on the second test, then you write like this. I probably take some point off. It'd be half of the point. Because if you write this, you see that all the formula we have on the whiteboard, and all the trigonometry formula, they always have argument. They always have angle. And if you write just tangent, for example, I just write over here, sine. I throw away my A and B. And then it doesn't mean anything. So make sure that you must have your argument here, okay? Your angle there, okay? So for the same thing. Okay? Alright, example. Let's do another example related to this. Let's see. I'm going to erase this. Any questions so far? And see, even now we're not talking about verification yet. We just talk about calculation, not verification. So if they give you the expression and ask you to verify, then you have to memorize all of this. There's a lot of things you have to memorize. All right, example 2. Something related to this. Let's see. How about this? Okay, should we give you the simple one? I want to write any question?
Yeah.
I want to write sine 2 theta minus sine 4 theta as the product of 2 functions. Alright. Oh, you just need to add the minus sign here, guys. I'm sorry, I missed the minus. I missed the minus. So add the minus. Answer. Okay, so in this example, I want to write this, the difference between 2 sides, as the product. Oh my god, it's easy right here. The difference between 2 side functions, the angle is different right now because for the formula they use the simple angle, the single angle A and B only, but we have over here we have 2A and 4 theta, 2 theta and 4 theta. So we treat it as A and B. Okay, so nothing new. Just the same thing. So using side A minus side B is equal to cosine
3 theta.
Let me write a formula. 2 cosine A plus B sine A minus B over 2. Okay. Okay. And now my A is this. This is my A. Right. This is my B right here. Okay. So I just applied it. So we will have sine of 2 theta minus sine of 4 theta equal to 2 cosine. A will be what? 2 theta, right? So 2 theta plus 4 theta is 6 theta over 2. We're going to simplify later, okay? Sine 2 theta minus 4 theta over 2 will be negative 2 theta over 2 equals 2 theta minus 4 theta. 2 theta minus 4 theta is negative 2 theta. Okay. And now I simplify this. Okay. So I have 2 cosine 3 theta, or 3 theta we cannot do anything, so just leave it like that. This will give you times sine of negative theta. Right?
Yeah.
Okay. Alright. The question I have for you, let's check if you memorize it now. Sine of negative theta equal to? It's an odd function?
Negative sine of theta.
Negative sine of theta. Very good. Yeah. So negative I put it in front. And we don't want to put negative over here, okay? No, okay? Because if you put negative here, then a lot of people will think this is cosine theta minus sine theta. So don't put, this is in the front. Okay. So that is very easy, typical example that when we use the formula here, okay? You see, you take a look at the sample test. Okay, let's go and take a look at the sample test. You see that number 3, right? Number 3. I asked you to find cosine of x plus y. Oh no, we don't even cosine of x plus y. We don't even need this over here. Oh, that's good. Oh, that's great. You see, in the sample test, you don't have to learn that. Okay, but in the homework maybe you have to use one of this. You see that for 4b, for example, 4b, we don't use this, but we use the double angle sine 2x. You see that? And half angle, I also give you the half angle identity already over there. So you want to prove from sine 2x over equal to the cosine square x over 2. Okay. So you should be able to do 1, 2, 3, 4 at this moment. 6 also. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. Find about the inverse function. We're gonna learn it next time. Okay. All right. I have some problem here. Now this is for training. And it's about verification. And I want to get together in group. Okay, let's do a group of, let's do again 1, 2, 3, 4 over there. Okay, about 1, 2, 3 here, and 1, 2, 3, 4 there. I want to get together and try to do this. So this is a practice. Verify cotangent alpha plus tangent alpha equal to 2 over sine 2 alpha. Okay. Alright, let's get together, guys. Get closer. Please get closer in group. You guys need each other. Okay. And 4 of you guys get together. Okay. Alright, I want you to discuss, talk about how we start this one using the formula we have learned so far. Okay. And remember, every time we talk about verification, and there are 3 strategies, right? You can go from left to right, right to left, or you can go for both sides. Okay? If you go for both sides, then your final will be something truthful all the time, something makes sense all the time, no matter what. Then it means that you already proved the trigonometry expression, or you already verified the It's up to you. It doesn't matter which one, what side you want to start with. But again, you always start, in my experience, you always start with the side that has more function. Okay.
The chairs.
Oh, the chair. Oh. It's really weird. Melissa, can you turn around and talk to me? Yeah, instead of being isolated like that. Alright. Okay. I haven't done this, you know, I try to see how we do this. So let's do it together. Okay, you have a few minutes, I have a few minutes. Let's see.
Yeah.
Let's see. Okay. I just see that maybe we can go from left to right. Left to right works. Oh, jeez. Okay. How about the other group? Anyone's?
I can participate.
Let's wait a little bit more. We still have time. Okay. Let's see. We can do from right to left or not. Yes, we can. You can do from right to left too, if you want to. Okay. You do from left to right, Peter? Left to right or right to left?
Both.
You will do both sides? Oh, okay. You do on both sides.
Kind of both, yeah.
Okay. How about the other group?
Yeah.
Just wait a little bit more. So in the textbook, if you have a chance to take a look at the textbook online, your Pearson My Math Lab, you see that there's a bunch of verification of problem there. If you need to practice, you have to go to the textbook.
Textbook is so weird.
It's weird?
Yeah.
What do you mean weird? What do you mean by weird?
It's just like
The way they
give
show?
like way too many like simple practice things, like a lot of questions, and by the time I reach something real good, I'm tired of these like 20 of these little ones. You know what I'm saying?
Like in the practice section?
Yeah, like in the practice.
They're like 50 problems?
Yeah, like 50 little ones, and then by the time you reach something that we do here, I'm like fried.
Oh. And you just need to spend more time. You just do all little things there. Well, in order to be good at it, yes, you have to practice. Alright, any idea of this first group and second group there?
Yes.
How about the other group? First group? Any idea? Yeah, you don't want to get stuck on this problem on the test, you know, because it's a part of our textbook. All right, Junior or Sama, you want to go over there? Yeah, so okay. Let's see how she did this. Okay. Okay.